All right, so now we have our data, and I'm going to go through two processes to create first a heat map that just looks at density of points across the cities, and then an interpolation map that looks at the values of the number of check-ins in all those locations. Okay, so we're about to engage in some spatial processing. So you remember the first thing we need to do is change both the coordinate reference system for the map we're working in to make sure that all of our new analysis happens in a projected system, and also reproject our point file to a projected coordinate system. So this is just like last week. Before we start any spatial analysis that has to do with linear dimensions, we want to first change the project properties, change the CRS of the project to World Mercator. Click OK. We have on-the-fly projection turned on, so we still see our data, even though this is still in WGS 84. The second thing we want to do is go to Save As, specify a new name, and this will be the projected data. And then here, specify a World Mercator. Instead of the WGS 84, which it is now, we're going to basically save as, and in the process, reproject it to World Mercator. Add that to the map. Okay, so here it is, it's overlaid. But now if we go back to our project properties and turn off this on the fly, you can see that the other data has disappeared. Okay, but this way we're sure we see the units below, it's in meters. Now we can make sure we're working Mercator. That's all we need sort of to do before we engage in. If you're working in this and you see degrees down there, that's going to be a problem to do any of the heat maps or spatial analysis. Okay, basically you're going to have to specify your distances and metrics in degrees. It's not going to make any sense. Okay, so now we have our setup. To do the heat maps interpolations, they're in the raster rollout up in the menu bar. These are things that you might have to turn on as plugins as well. So if you're not seeing here heat maps interpolation, this is a basic interpolation. I'm actually going to show you another interpolation that's down here in analysis grid interpolation. If you're not seeing any of these tools, go to your plugins manager. You can search for them, heat map, and make sure this check mark is ticked, okay? All right, so the first thing we're going to do is create a heat map. Just go to heat map here. It's going to ask us for an input point layer. That's our data, right? We have food. Make sure you're using the projected version. An easy way to avoid making mistakes is just to delete all the layers you're not going to use. For output raster, I'm going to specify a name again, and this is going to store it as a TIFF. So this is going to be an image file I create. I'm just going to call it heat map. All right. Now, there's two main parameters you have to specify for the heat map, and those are going to relate to what your map ends up looking like. The first parameter is the radius. This is the radius that's going to search to figure out if points are close to each pixel. And like I showed you in the PDF, the lower this number is, the more localized the search, the more concentrated the hotspots are. You're going to get a larger number of smaller hotspots. If you make this value a lot bigger, you're going to get a smaller number of larger hotspots. Okay? And this is specified in meters, basically. It's literally the radius that it searches. I'm going to start with a pretty closed-in search, 500 meters. Remember, use the 500 meter grid last week. 500 meters is typically a good place to start for urban spatial analysis. And then if you click Advanced, you're going to get options to specify the actual resolution of the grid. So in this case, the dimensions in meters of each pixel is specified right here in cell size. Okay, depending on your aspect ratio of your data, this is the total number of cells. This number is important to look at to make sure you're not going to create a raster that's too big and it's going to take forever to process. Okay, so something like this with 200 by 200 pixels and this many length by width is pretty good. So I'm going to click OK. All right, so there it is. That was very quick because of the parameters, very low resolution. Raster, if I zoom in, I can clearly see the pixels. If I use my measuring tool, you can see that these are exactly 200 by 200 meters. One thing it does, for some reason, this might be a setting, but when you output this heat map, it'll convert it into a WGS 84 again. Okay, so if we want to see those meter values, you just change it back to World Mercator. I'm not sure why it does this. But now if you look at the distances, these are 200 by 200 meters. Now, this is an image, right? It looks like a very pixelized photo, but it stores data. All the values here, they're visualized black to white. They're actually just visualizations of data, and the data behind this is the density of points near that pixel, okay? So just like with shape files, you can investigate the data behind each pixel. You can use this identify features tool to actually click on a pixel. It's going to show you this heat map. See derived. This is just saying this is not actual data. It's an interpolated kind of derived data, and it's going to give you this number. This number actually means something. Okay. So this is the basic visualization, black to white, but we can visualize these raster images the same way that we did with shape files. Now if I drag this under, you can see the overlaying of the points on top. Kind of verify that makes sense. The denser areas have more, are lighter in color. If I double click on the heat map, I have a similar display of properties for that layer. And if I go to style, I can style this in different ways. So this is a slightly different interface than for shape layers, because now we're going to be dealing with how it assigns color to those values rather than coloring shape vector files. Okay, so I won't go too much into this. Typically, if you're dealing with one type of data, so here I just have a value that corresponds to density, you can use single band gray. That's the default, goes from black to white. You can also use single band pseudo color. This will let you color your data with a custom gradient. This is the same thing we did for coloring values with point files. So I'll specify maybe reds. Not sure if I want to invert this. You do classify. It's going to take the lowest value and the highest value in your raster and assign colors based on that. So in this case, I want the highest value to be the darkest, so I'm going to invert this. And maybe just to match my reference from the beginning, I'm going to pick this blue gradient. And then you can specify it's continuous, which will try to estimate the number of values you need, or you can specify the values yourself. So I'll pick 9 classes from the smallest to the largest and hit apply. Okay. So there you can see our heat map. We used a very small radius, so you get a lot of these smaller hotspots. And just to show you how this works, if I go back to heat map, I'm going to specify everything the same. And here I'll just say heat map 2. And I'll use a much larger radius. So here I'll say 2000. And then a much smaller size of grid. So I'm going to pick 100. Okay, keep everything else the same. Click OK. It should take a little bit longer, but you see what happened compared to the other one. Now it's a much higher resolution. I'm actually going to color it or visualize it the same way so you can see the difference. Oops. Okay, so you see what happened. A lot of the heat, the hotspots start to glom together because it's looking over a larger field. And also the resolution has increased quite a bit. Okay, so if you're looking for this analysis at the scale of a city, something like 100, maybe 50, starts to look really smooth. Okay, you don't want to push it too much. So this value is the size of each pixel in the x dimension. This is the number of pixels along the x direction. So if you know you want an image of a certain aspect ratio, like you want 2000 by 2000 pixels, you can plug in these values. Usually it makes a lot more sense to specify the size of the pixel and let QGIS calculate how many pixels there's going to be. Make sure that in your map, these numbers are really big. Make sure you're working in meters, because you might be working in degrees. So you can do it, you just have to specify a very small increment. But again, because we're doing spatial analysis, working with degrees doesn't make sense. You want to just make sure to reproject your data and make sure in your project's properties you're working with the Mercator projection system before you do this. Yeah, but that's a very common problem. If it's not working, you're getting very large pixels. It's because you have to reproject it. All right, so that is a heat map. Hopefully that makes sense. It should be pretty obvious. So this is, if we look at this, what we're really doing is just looking at density, which is interesting to a certain extent, right? For a lot of data, it's just important to understand how certain points or things are distributed spatially in a city. So heat maps, they're interesting for analysis, and a lot of times they provide a pretty good base level kind of exploratory graphics. Something like this might be a good way to show the density of check-in locations in the city. In our case, we want to go a little bit deeper. We're not just interested in the location of these things, but also how many people are actually checking into these locations. So a natural extension of heat maps becomes interpolation. It does the same basic thing, but looking at values as well as spatial location.